Now, my talk here is about probably one of the topics we think we do better at than we do, and that's human error. I'm going to talk a little bit about what we can learn from safety-critical industries, including aviation. This is a short talk, so if you have questions, I'll probably take them outside after. Now, this was written for a more database-centric talk, but for the audience here, I have about 30 some odd years of experience doing everything from customer support, database operations, DevOps, even running DevOps teams and things like that. This human factors topic is probably my favorite topic to talk about. It's more important than getting the right technology in place because we're all humans at the end of the day, and as much as sometimes we cause problems, we're the only people, or we're the only things that get us out of those problems, right? So that's that. This talk is about two things. It's about things our industry doesn't do very well, and it's about us because, you know, we're the human factors. How many people here think we address human error well? Nobody. See? Now, we're going to talk about something kind of along these lines. Now, how many people here have been on a team where something's gone wrong and you've had to escalate and somebody's had to work on a production system, a critical production system when they're drunk? See, what, about half, more than half? How many of you have seen this cause a major problem? A couple people. That's more than I've seen in any other talk, by the way. So it occasionally does cause problems. Now, how many of you have seen a major outage that happened because somebody was working on a production system and they were tired? See? Almost everybody. So if you have to choose between somebody drunk working on your production system and somebody tired working on your production system, yeah. Yet we valorize people coming in and working on stuff when they're tired. We don't say, you're tired, go home, you're putting our operations at risk, right? Instead we go, thank you so much, you're so dedicated, you're coming in, you're helping us out even though you had a terrible night of on-call. And oftentimes we're not really aware of how this causes problems down the road. This is probably the biggest topic in sort of the lowest hanging fruit that we can address here. One of the interesting things is there have been a number of studies, and if you are going on only 4 hours of sleep, that can impair your cognitive skills more than a few drinks. So more than what we would consider to be well over the line in terms of operating a motor vehicle. And I'm not saying, by the way, that tiredness is always worse than drunkenness. Obviously, operating motor vehicles is a case where the coordination and timing of the controls works against that statement. But in terms of our field, it seems to be our general experience here that tiredness is a bigger problem and it causes more problems for us and we really don't deal with it. So that's sort of an eye-opener, and it should be something that we look at when we try to decide how to improve our own operations. So I want to talk now about an industry that's done a very good job of looking at human error, and we're going to look at aviation. Now, 60 years ago, 90% of aviation accidents were blamed on pilot error, okay? They've moved from pilot error to human error because it's no longer about the pilot did something wrong, it's about the human brain made a mistake, and we want to understand that mistake and redesign things so it doesn't happen anymore. Today, that number is still 80%. Okay? But aviation has gotten 100 times safer. That means that not only are we 100 times better at avoiding technical faults in aviation, but we're 100 times better at avoiding human faults in aviation. Okay? But when we look at our industry, we're still looking at human error the way they looked at pilot error 60 years ago. When we see human error on a postmortem, how many people here actually dig further and say, what kind of error did the person make? Why did they make it? What do we need to change about our work environment to keep it from happening? Anybody? Couple. That's good. Respect. Now, this was part of two major trends in aviation. The first was trying to understand why people make mistakes and find ways to avoid that. The second one is a shift from individual responsibility to collective responsibility. And as an industry, we've done that one better, okay? Our concepts of blameless postmortems are entirely in line with that, okay? But this is something which we still have quite a lot of room to improve on, especially when we start looking at how we can like dig deeper into the human factor in our postmortems. So I'm actually going to go over the last 2 points on this slide in reverse order. In 1969, David Beatty wrote a book called The Human Factor in Aviation Accidents. If you're not a nervous flyer, it's a great book to read. If you are, find something else on this topic. Because all he actually does in the book is he looks at categories of mistakes that happen. He doesn't talk about like solutions, but he talks about categories of mistakes. And he's really looking at things like, what does fatigue do, stress, right versus left confusions, things like that. And this was really the beginning of trying to understand a taxonomy of human error and why we make mistakes so that we can reason about how to fix the environment so that we don't make those mistakes in the future. This was driven home after the Tenerife disaster. I don't know how many people here are aware of what that was. Few. Basically, in Tenerife in 1979, make a long story short, there was a KLM 747 that tried to take off without a proper takeoff clearance down a runway in Tenerife in the Canary Islands, and it hit another 747 on the runway. Most deadly aviation accident in history, okay? And it happened on the ground, so. So the Spanish report was more or less aimed at pointing fingers at both the air traffic controller for confusing language and also the pilots for not properly taking off with a clearance. The Dutch report was very different. What the Dutch report focused on primarily is why did the chief pilot of the KLM fleet take off without a proper airline clearance? And they came up with several reasons for this, but one of them, which is really important here, is that at the time, the chief pilot wasn't flying a lot. He was in a simulator most of the time, and as a chief pilot, he was the one giving the clearances. This was a high-stress situation, and what do people do when they're stressed? They revert to what they're used to doing. So, he's used to giving his own clearances. He's going to act as if he's given his own clearances. The result was quite a number of people lost their lives. So, needless to say, they don't do that in simulators anymore. They learned that lesson and they fixed it. We have a lot of work to do in our industry. So, in our industry, we see one solution to human error, and that's automation. And this is a bad solution in general to this particular problem, okay? The IEEE, folks at the IEEE have done a really interesting amount of work on something they call the automation paradox. And the automation paradox is basically that the more reliable an automated system is, the harder it is for a human to correct it when it's going wrong. Good example was a cruise ship that ran aground in, I think, New Jersey a couple of decades ago. The process was people were supposed to check the GPS and calibrate it every day. But what had happened was the antenna came off. And very slowly things started to diverge. And nobody noticed this because, you know, of how we process information. Eventually it ran off the ground, ran aground and off the coast of, I think, New Jersey. And if any of you remember that story, you know, there was a major rescue effort that had to go towards getting people off, getting food on for those that they weren't getting off at the time and stuff like that. So, this is a real problem, and it happens because we think we're fallible, machines are infallible, and we don't really have a clear understanding of how we work together to resolve problems. way we need to think about automation isn't automation as a way to fix human error. The more automation we throw at that problem, the worse it's going to get. We need, in fact, to be thinking about very deliberate automation, making sure that steps that have to occur together are automated together, but also that we have appropriate decision points and transparency along the way so that the human operator is actually not only aware of what's going on, but actually in the loop and an active part of the decision making. So obviously, we have to decide questions of how much feedback to give. Those will be dependent upon specific circumstance, but we can generally figure that out. I usually think, a lot of people say checklists are the first step to automation. The way I think about it is you should write your automation around a checklist rather than the other way around. This is what you should see, then you do the next step, this is what you should see, and you build your automation around those steps so that somebody's actually paying attention to what's going on and they're fixing the problem, or they're able to say, this isn't going right, we're not going to continue, we're going to do something else. Why do we make mistakes? So the thing is, machines are mathematical, our computer softwares are mathematical machines that basically take input and produce output in a deterministic manner most of the time, unless you're dealing with AI, in which case, who knows. The thing is, we're not. We operate in an open world. We have no ability to, or we have no assurance that the information we see is all of what's out there. So humans are primarily inductive organisms. We think, we make induction-based logic around what we see. And so our contribution to the success is very, very, very different from a machine. That also means that there are things that machines are much better at than we are, right? But it also means that in order to function, we have to have cognitive biases. Confirmation bias is one of them, and it gets a bad rap, but we wouldn't be able to function without it. Continuation bias is another one. Those are big issues. Other things are environmental, stress, fatigue. Those are things that cause big problems for our industry, and we need to do better on that. Final one is overload. Too many things happening, we're going to start filtering, we're going to start prioritizing, and we're going to start dropping things, right? Sometimes we're going to drop the wrong things. If we start to understand why we make mistakes and we have a good taxonomy for that, we can avoid a lot of problems. So then this gets to the question of how do we debug the human? And this is sort of where I'm getting at here, is that we need to go away from this idea that we eliminate the human, and we need to get to the point where we can debug the human aspect. And the big thing here is we actually need a good understanding of categories of mistakes. We need a taxonomy of human error so that we know this mistake happened, we have an idea of where to look to fix the problem. Somebody did something that they're used to, policy changed not long ago. Maybe the problem is stress, and we need to figure out how to better manage that, right? So this means we also need a good understanding of cognitive biases. There are social factors like power distance, which I'll talk about in a moment. And we need to be able to understand the person in a clearer context. So as far as social tensions, as I say, conformity, it's power distance, those are big issues. We need to be able to think about this from a work relationship perspective. Basic point here is that we need people to be in decision-making roles as inductive, people actually doing the inductive work and leaving the deductive work to the machines as best we can. This is a shortened presentation, so I'm skipping forward rather quickly. Big thing that I think we have to do in order to solve this problem is we need to implement some of the things they've done in aviation. We need good crew resource management. This probably means bringing in crew resource management trainers. Right now, most of them are doing most of their work in aviation, but many are doing work in other industries like medicine and stuff like that. Find people who are doing multiple industry trainings, bring them in, but do so with an organizational backing that says we're actually going to fix these problems, because you know, the promise is that we can improve our throughput, we can improve our efficiency as well as our reliability, and then everybody does better. So those are really important pieces to this overall thing. So the roadmap to doing this, the first thing is you have to get organizational commitment. If upper level management isn't there with you, you can do all the other steps and it'll still be helpful, right? When I did this at Adjust, we were able to dramatically improve our run books for things like Aerospike, but because we didn't have upper level management support for the overall problems, we couldn't fix it for things like fatigue. So you need to get that, then it's good to bring in some trainers, get a core group of people, including some managers trained, and then have them training everybody else. And also the core group can be involved in postmortems because now they'll have a solid understanding of things like why we have mistakes, how we make mistakes, why we make mistakes, and all the rest of that. So, just want to say, I think that this is an area, as an industry, we need to do much, much better at, and yeah. Want to give thanks to Adjust, where I actually managed to implement some of this. Delivery Hero, where I was involved in implementing some more of it. Timescale, they paid me to come here and do this talk, and I'm helping them implement it. And I think that these are things that I've seen a lot of benefit to. So if you have questions, I'd love to talk to you afterwards. I don't think we're going to have time here in this session. Thank you.
Thank you so much, Chris.